Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, welcome back to mathematics class. I am Miss Subaru Favor and we will continue with our topic on logarithm. And we're looking at the multiplication and division of logarithm numbers. And the previous examples we looked at, we were telling us that logarithm to the logarithm whose base is base 10, that is the common logarithm. And in this case, it is preferable to write the given numbers and logarithm in a tabular form. Unlike we did in the previous examples, it is preferable and will have a clear work and a neat work by presenting our data in tabular form. So we'll have the first example. So in the table, this is how it's usually arranged, where you have the numbers here and the logarithm here. So the first number we have from the example, we have 5.932. And if we should check for 59 under 3 from our 4-figure table or logarithm table and the difference of 2, we're going to have 0.7732. And from our previous classes, we discussed how we get these characteristics here. That is from the numbers, the digits we have here. So we'll have 0 because what we have here is 1, and when we subtract 1 from that one digit we have, we're going to have 0. So 0.7732 is the logarithm of 5.932. Now that is for the first one. And the second number we have 8.164. Checking 81 on the 6 and the difference of 4, you're going to have 0.9119. Okay? And remember, in our previous class, we said this has to do with the laws of indices. Remember, we are dealing with common logarithm with a base 10. So that means 10 raised to the power of 0.7732 will give this. 10 raised to the power of 0.9119 will give 8.164. So that means these logarithms here, they have the same base, which is 10. And in our laws of indices, when you have the same base, you can simply add the powers. So the third number we have 18.51. 18.51, we check 18 under 5 difference of 1, we're going to have 0.2674. And mind you, since the connectivity between all these numbers is multiplication, we are going to be adding the powers. Remember, we said logarithm means powers. So that means 10 raised to the power of 0.7732 we give this. 10 raised to the power of 0.9119 will give 8.164. And 10 raised to the power of 1.2674 will give this. So you will agree with me that all these numbers here, they have common base, which is 10. So we are going to be adding all of this according to the laws of indices. So by the time we add 0.7732 plus 0.919 and 1.2676, the results will give 2.9525. Okay, so this is the logarithm of these numbers when multiplied. And how do we get the exact number? That is, we will check the anti-logarithm table, and in the anti-logarithm table we check for 95 under 2, difference of 5. 95 under 2, difference of 5. That is from the anti-logarithm table now. So we will have 8964. 8964. If we should check for 95 under 2 in the anti-logarithm table, difference of 5, we're going to find this numbers. And remember, we said in our previous classes that the characteristics from this place is just giving us the positioning of our decimal point when we find the anti-logarithm. So when we add 1 to this 2, it's going to give 3. So that means after 3 digits, then we'll have our decimal points. So the anti-logarithm will be 896.4. So that is the result from the multiplication of this. In example 2, we had to calculate the cube root of 218 multiplied by 37.2 all over 95.43. Please take a look at the question. The cube root covers everything. It's affecting both the numerator and the denominator. So we have a table set. Here we'll have our numbers and then the logarithm. So we are going to pick them one after the other. The first, we have 218. 218. Now the logarithm of 218, we'll simply check for 21 under 8. And we'll have 0.3385. 0.3385. And the characteristics is 2. If you've been following from the start. So that is for the first number, 218, and this is its logarithm. The second one, we have 37.2. Remember, the connectivity between these two is what? Multiplication. So the logarithm of 37.2 will check for 37 under 2. And if you check that from your 4-figure table, you have 0.5705. And the characteristics is 1 from the numbers of digits we have here before the decimal. Now, if you look at the question, the connectivity is multiplication. And remember, we are dealing with common logarithm. The base here, despite that we are not showing them, the base is 10. So they have common bases, and in that case, we're going to be adding the logarithm since they are multiplying themselves. So if we add 213385 plus 1.5705, we will have 3.909. Okay, 3.909. Now that is for the numerator. The two digits we have in the numerator, 218 multiplied by 37.2. That is it. And this is what we have from the numerator alone. Now, picking the number we have at the denominator, which is 95.43. 95.43. And if we check from the logarithm table, 95.43, if we check for 95 under 4 and the difference of 3, we're going to have 0.9796. 0.9796. Remember, this is still the solution of the numerator repeated here, 3.909. Now for the denominator, this is what we have, 1.9796, considering the characteristics and then the logarithm. So that is that. Now from the numerator and the denominator, if you look at the numerator and the denominator, the relationship or the connectivity between them is what? A division sign. So, and since they are dividing themselves, we will simply subtract the logarithm. So what we had from the numerator, which is 3.909, minus what we will have from the denominator, which is 1.9796. 1.9796. By the time you subtract that, you will have 1.9294. 1.9294. Now, we've dealt with what we'll have in the numerator and the denominator. Now, we've not looked at the cube roots we have outside. So this is the solution from the multiplication of 218 times 37.2, and then all divided by 95.43. This is it, 1.9294. Now, considering that we have our cube root, we have to take the cube root of everything in here. So that means from the laws of indices, like we looked in our previous example, the cube root of any number is the same as that number raised to the power of 1/3, and that is going to affect only the power, which is the logarithm. Remember, logarithm means power. So 1.9294 divided by 3. So if we divide that by 3, we are going to have 0.6431. 0.6431. So this is the logarithm of the multiplication and the division, and then the cube root of the numbers we have. So 0.6431. Now that means 10 raised to the power of 0.6431 will give a number, which is the antilog. That will take us to the antilogarithm. Finding the antilogarithm of this number, we'll check for 0.64 under 3 and a difference of 1. Then there will have 4397. 4397. And from the characteristics, which will give the exact position of the decimal point, we will add 1 to this 0, then we'll have 1. That will tell us that after 1 digit, we will have the placement of our decimal point. So the antilogarithm of this number right here, 0.6431, will give 4.397. 4.397. So thanks for watching, and please don't forget to subscribe to our channel.